You may pause the video and try this by yourself first. What volume of oxygen gas is needed to completely combust 0.202 liters of butane gas? So it's a combustion reaction, so let's write the equation first. So we got butane gas, C4H10, plus combustion, so in presence of oxygen, we're going to produce carbon dioxide and water. Okay, let's balance it. You got 4 carbon here. I'm going to put 4 here. That's going to make, and then there are 10 hydrogens there. So I'm going to put 5 here. But if I do that, I'm going to make odd number of oxygen. And here the subscript is 2, so it's always going to be even. So a good way to fix that is multiply this by 2, make it even. 2 times 5 is going to be 10. So I'm going to put 10 here. That just made 20 hydrogens. So I'm going to put 2 here to make it 20 hydrogens there. Then there's 8 carbons. So I'm going to put 8 in front of carbon dioxide. Let me see. So that's going to have 8 carbons and then 20 hydrogens. So that's set. How about oxygen? 8 times 2. And then there are 10. So that's 26. So I need to make 26. I need to put 13 here. So I think that's it. Okay, by balancing the equation. Now let's start with whatever we're given. We're given 0.202 liters of butane gas. And then we need volume of oxygen. So let's go step by step. At STP, you should know that in 1 mole of any gas, 1 mole of any gas will occupy 22.4 liters. So we have 22.4 liters. I put liters on the bottom so we could cancel that. It could be any gas, so I'm just going to put but for butane. That's 1 mole of butane, but. Now we use stoichiometry. We're going from butane to oxygen, so that's 2 moles of butane and then 13 moles of oxygen. Actually, you don't need to put 22.4 here because it will cancel out eventually, but I'm showing all the work in detail. Let me make some room. And then multiply by, so but cancels, and then in 1 mole of oxygen, remember at STP, it's gonna make it's gonna occupy 22.4 liters of space. Okay, so that cancels out. See earlier what I meant? That 22.4 number-wise, they're gonna get canceled out too. Okay, so the left unit is liter of oxygen, so all you need to do is just multiply all the numbers on the bottom, on top, divided by numbers on the bottom. And then 3 sig fig, it's 1.31 liters of oxygen. That's the answer for this problem. Let's do another one. This problem, we're not at STP anymore. First of all, we have propane now, and then it's at 25 degrees Celsius, and then pressure is not 1 atm, it's 1.04 atm. Okay, again, it's a combustion, so let's set up an equation first. So we got propane, C3H8, in presence of oxygen. We're going to produce carbon dioxide and water, just like the other one. Okay, so there are 3 carbons, so I'm going to put 3 here. And then there are 8 hydrogens here, and I have to put 4 here. You see how oxygen is everywhere? So I like to balance it at the end here with that oxygen. So now let's see, how many oxygen do I have on the right side? That's 3 times 2, and then 4 times 1. I have 10 oxygen, so all I need is 5 there, and that should be it. So when we talk about volume and any type of gas, think about PV equals nRT. Okay, so we're finding the volume here, so let's solve for V. It's going to be nRT over pressure here. So R is given, that's gas constant. T is given, pressure is given. However, this number of moles of oxygen is not given, so we don't know that. Okay, let me summarize it here. So we have N, we need to find it. We could find this, okay, not given, but can find it. I'm just going to put question mark. R is gas constant 0.0821 liters ATM over mole, and then K on the bottom. Temperature is given. It's at 25 degrees Celsius, but we need K, so we need to add 273. That's gonna be what is that, 98 kelvins. I'm not using decimals, 1.15. P is at ATM, so 1.04. So all these are given, and this is what we need to find. Volume is the ultimate unknown. But N, we could find it. How? Well, we'll start with 5.53 grams of propane, and we do stoichiometry to find number of moles for oxygen here. Let's do that. Okay. So I use different color for stoichiometry portion. So let's start with what we have. 5.53 grams of propane. I'm just gonna write prop, short for propane. And then let me see, 12 times 3, molar mass for propane, 12 times 3, that's 36. I'm not using 12.01, but it's okay, it should be enough. And then you add 8, that's going to be 44. So 44 grams of molar mass. Prop should equal to 1 mole of prop. Let me erase this. And then we're going to go to oxygen, so it's 1 mole prop, propane to 5 moles of oxygen. Okay, if we stop here, you see how all the units get canceled out, except we have number of moles for NO2. Okay, number of moles for O2. That's what N is equal to. So we did all this to figure out what that is. Okay, let's see. Let's go. That's 0.628 moles of oxygen. See how everything's about oxygen now. Okay, so that's done. So all we need is solve for V now. Remember, PV equals nRT. So I'll write it again. V is equal to nRT over pressure. Okay, you have all the units here. So I'm not going to write the units. I'm just going to put the numbers here. 0.628, that's number of moles. Gas constant. Temperature, 298. Everything over 1.04. 3 sig fig. So volume is going to be 14.8 liters of oxygen. That's how you do this problem.